Okay, when we're dealing with payout annuities, sometimes we know how much money we're starting with in the account, and what we'd like to do instead is figure out that if we had this much money, how much could we actually take out for a regular period of time. Let's do this idea. Let's suppose that you got an inheritance from some great aunt that passed away of $20,000, and you decided that you wanted to use this to help you get through college. You wanted to, your aunt loved education and wanted you to spend this money on the tuition for your schooling. So the idea here would be that you figure you're going to be in college for 4 years. Let's do it with 4 years this time. And every quarter, what you do is you would like to take out money to pay your tuition. So spring quarter, summer quarter, fall quarter, winter quarter. So this is the goal that we'd like to do. Currently it's sitting in that 3% interest account. We've been having fun with that amount there. And what we'd like to do in this particular case is we would like to see how much can we withdraw every quarter. So how much can we apply towards tuition while we're still hopefully continuing to earn that 3% interest on as much money as is left for as long as possible to maximize our returns here. All right, so this is our goal. Our payout annuity formula is this, because we're starting with a large amount and then taking money out. So we're using the payout annuity version of the formula. As I go through here, D is what I'm trying to figure out. How much money can I actually withdraw? In this case, P naught is my starting amount, which I am starting with that $20,000 inheritance from my aunt. R is my annual interest rate, which in this case is 0.03. K is my compounding period. This time I'm doing it every quarter because I'm going to use it to pay for my different schooling areas. And so every quarter is 4 times a year, so that's going to be a little bit different than what we've done in some of our other problems. N is the number of years that we're going to be wanting to do these withdrawals, and in this case that is also going to be 4 because we figured that we were going to actually try to stay on target and graduate with our degree in a 4-year period. Cool. All right, now at this point we're going to plug everything in the formula. So just following along up here, P naught is $20,000 equals D, I don't know, but it's 1 minus 1 plus R is 0.03 divided by K, which is 4 this time, to the negative 4 times 4, because 4 years, 4 times a year, because we're compounding quarterly. Oops. Let's see here. There we go. I do want to put that negative 4 times 4 in parentheses, but we'll just put the whole thing there. That's a little bit better. Close that off, and then it's all divided by R divided by K, which was 0.03 divided by 4, which is the number of compounding periods. So here's my equation. Just like before, notice that we want to solve for D. There's only one D. All of this is together. It's D times this divided by this whole big thing. The easiest way to do that is just go ahead and evaluate all of this stuff together because it's D times by all of that. And so if we can evaluate that and get a simpler problem, and then we can solve for D from there. So that's the strategy I like to generally use with this sort of thing. All right, this we can just all enter very carefully and conscientiously with our parentheses, but we can plug that whole thing in on our graphing calculator. So let's clear our screen and look at what happens. We start with the parentheses on top there, 1 minus, and then introduce a second set of parentheses. Then it's going to be 1 plus 0.03 divided by 4. Close the parentheses, and now I want to raise this 1 plus 0.03 divided by 4. So use the caret button to take that to a power, and then use the parentheses to make sure everything gets in the exponent there, to the negative 4 times 4. Close the parentheses, and if you're physically high, then use that arrow to get back down to the main level again. Keep in mind we do want those exponents to be in parentheses there, and make sure that in front of that value, in front of that 4, you use the negative button here and not the subtract button. If you try to do a subtract button, you will get an error on your calculator, which will make you unhappy. Now notice that here, this is our exponent, and then we have to close the parentheses. Make sure to do that. It's not, the calculator gets mad if you don't have the right number of parentheses in your problem. Then it's going to be divided by, parentheses again, 0.03 divided by 4. Close the parentheses, hit enter, and this will give me my value of everything in the big red box. So as over here, oh, I'm in red, but that's all right. So over here then, what I've got is I've got that 20,000 equals D times this value here, 15.0243, blah, 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 blah. And then to finish getting the D by itself, just divide by that 15.0243 number on each side. So here I've got 20,000 divided by, I'm just going to use that second negative to bring up that answer, previous answer. And what I end up with is $1,331.17 or 18 cents that I can withdraw every quarter to apply towards tuition. And so if the tuition for a particular quarter worth of school was more than that, then I would have to make up that difference by working or whatever. But to balance the value of my aunt's account over time and take advantage of that interest so that it's continuing to earn interest as I make my withdrawals, this is the magic amount that you would want to pull out. And that would give you the amount that your annuity was going to provide you with each quarter, because we were using that K equals 4 for my withdrawal times here. All right, so with that, give that last payout annuity problem a whirl, and then we'll come back and talk about loans.